All right, everybody. Sorry for the delay on getting this video out. I didn't feel comfortable with getting this recorded and being able to do it until I was able to actually explain it. But I'm obviously being asked. Some of the stuff I've been posting on my actual progress, and I've been asked how I did it. So I figured that would be a good jumping point. So I'm just going to jump in and start getting these recorded. I will edit them very minimally, meaning I'm not going to spend a lot of time cleaning up the video. It's going to be is what it is sort of thing, but I will try to be in as much detail, and I will cut out a lot of dead time. I will show if I run into a bug along the way how I fix the bug or the error, so everybody's learning from it. Okay, so without any further ado, the first thing we have to do is figure out how we're going to program. Now, the tutorials that we were provided, I'm not a huge fan of, in that they do not allow for scalability, which I am a huge fan of, meaning I don't want to write the same code 100 times. That's kind of not a thing for me. So I'm going to go about it using the same techniques, but a different way around the barn sort of thing. So let's start with figuring out exactly what our process is going to be. All right, so the first thing we need to do is draw a triangle, because everything's made up of triangles. So the first thing we're going to do is figure out how we can create this shape and what's the best way of doing so. From there, we will go from that to figuring out how to do a square. And then once we have this building block, we're going to make it so we can reuse it over and over again. So we can then make more complex shapes as we go through, starting of course with the cube. And then as a few people have seen, as I've gone through, I've done a little bit more complex shapes. One of the ones I did was a cube that had holes all the way through it. Whereas I won't go over how I created each one of these more complicated shapes just because of time. I will go over how my code was reusable to make this process easier for me to go through. All right, so that being said, what we're going to do is get right into coding. I'm going to assume that we have the procedural mesh in, all the plugins are in and working, and all of that. So with that being said, let's go ahead and get right into the actual coding of everything. And what we're going to start with is the triangle and square. So we're just going to go ahead and call this actor, just going to call it basic shapes. Okay, so now that we're in here, we can start to do some things. So first thing we're going to do is delete these two. We're not going to use them. And then in here, we got to make sure that we delete these as well. And now we can go ahead and start right in here. And what we're going to do is we're going to make sure that we include the procedural mesh component. That's going to be a thing. All right, and now the next couple things we're going to need are going to be over here in the public. This first thing we're going to do is not needed, and it wasn't used before, but it's going to be needed for future. So we're going to go ahead and add it in. It's going to be a U property, read and write, and we're going to go ahead and give it a category. I'm going to call this category mesh parameters. It's going to be an F vector. And what this F vector is going to do is it's going to control the size of our shapes. So we're just going to call it the cube radius. I'm going to give it a default size. All right, so now with that one done, so we're going to come right down here to the protected section. And in order to give our actor form, again, this wasn't covered, but prior learning has shown that anytime you have an actor that's going to have a visual component within the game environment, you should have, can you guess it? Come on, go ahead. What should we have? You seen any guesses? What am I going to be typing? That's right, you seen component. I've kind of grown accustomed to just calling everything that is a component of this class this. So this scene. And then from here, we'll use the mesh. Okay, that's what's going to give our shape form. And then from here, because we're using a procedural, well, the procedural mesh component really, we're going to need two methods. Both of them are going to be virtual overrides. So virtual void. The first one is a post actor created method. And what this method does is it will trigger when, let me see if I can remember this. This will trigger when you drag the actor into your world or when it's spawned into your world within the gameplay. So if you have an auto spawner, when your function or blueprint method calls this actor and spawns it into the world, this is the method that's actually triggered. And then we have another virtual void, and this is post load. This method is fired when you open a world. So, and if you have a level and this actor is within inside that level, as soon as you open that level up in the game, this will be triggered. Now, the last thing we're going to need to really kind of do this is have another method, and I'm going to call this a generic generate mesh. Right, and this is going to be the method we use to declare our shape's form. That being said, it's important to note that we're going to need another method. We're going to need a few more methods, really. The first one being a way to do the triangle. We're going to create this triangle. So we're going to have a private section. And within here, we're going to create another method. It's going to be a void. And we're going to call this add triangle mesh. Now, this is going to need a few things passed to it. So when we're creating a mesh, we need a few components. We need vertices. So we need to be able to know what vertices define the points of the mesh. And considering we're going to do a triangle, there's going to be needed 3 vertices to be used. And the order kind of does matter. So let me get my pen back out here again. All right, so what we're going to do, because we're going to create a triangle, first thing we have to do is know that I don't know how to draw a triangle. That we're going to need to pass it the different vertices that it's going to have. So we'll call this one A. We're going to call this one B and this one C. Now, that being said, there's a few things we're going to need. One, we're going to need to know the order. We have to pass them into the method in the same order every time. So therefore, this is the order in which I am going to put them in, because we have to go on a counterclockwise pattern. So therefore, to maintain that, this is how we're going to do this. So our method, we're going to pass in the 3 vertices that we're going to need. And then we're really not done there. A proper mesh also has normals, right? So we know we're going to need a normal. And then we need a tangent. To accompany that, we have UVs and then color. It is important to note all of this is actually optional information you don't technically need, but it does help with shading. And when you get to more complicated objects, and shading is really important, it is good to know how it all comes about. So that being said, we're going to implement these as much as we can whenever we know it. All right. So, and I'll go into some of the more particulars of each one of these as I know it. But for now, what we got to pay attention to is what we do know and what we do need to control. and that is the triangles. We're going to manage the triangle. So we know we need that as parameter. The other stuff we can kind of fudge, with the exception of the tangent. And the reason why I say we can kind of fudge it is we're going to make the other ones, and actually all of these variables that we can access anywhere. So let's go back to the computer. Okay, so like I was saying, with this triangle, we're going to pass in, and we'll keep it simple at first. So for the triangle mesh, we're just going to go ahead and pass in the 3 vertices, and then a reference to the triangle index, and then of course the tangent, which are all things we're going to need to keep track of. We know we're going to have 3 vertices, and in the diagram I showed you, the first one is going to be, well, first off, they're all going to be F vectors. And then we're going to have a top left, save me typing, a bottom left, and then of course a bottom right. And then, like I said, we're going to pass it in a tangent variable as well, and an index. The index we're actually going to pass to it. So it's going to be an int32, and we're going to reference it. And then the tangent is actually an fproc mesh tangent, specifically for this class that we're using. All right, so that's our first declaration for our first one. And then, as I said, we're going to make, and I'll put them actually above, all of the variables public to the class instead of in the method. I'm just going to take a minute and enter these all in. All right, so these are the variables that you're going to need when working with the different meshes and creating procedural meshes. The first one, again, is the vertices. This is going to define the different points of the mesh and let the program know how to apply your actual static meshes to it. Your triangles, it's actually an int32, and that's just going to actually be a buffer, more of an address. I like to think of it as an address that's going to point to your vertices. It's actually designed to save memory by not having to have duplicate vectors, F vectors, variables out there. And int32 is a much smaller memory than the actual F vector variable. Normals actually tells the engine which way your surface is facing, and there's a formula for that, and I will go over that when we're actually applying it. And the tangent is actually the perpendicular angle to the normal. So essentially it's the 90-degree angle. I'm not too familiar with the formula to do that yet. I am working on that. And then of course the UVs lets the 3D renderer know how to apply the meshes and which pattern. And then the color, this is tricky. The actual definition of it says that this applies a color to the vertice. It's kind of misleading. Without any additional work, this will not directly affect the color of the static mesh that's defaulted on to the actor. I'm sure they will use it sometime at some point, but I haven't seen a difference yet. All right, so that being said, let's go ahead and get going on the code. I've talked too much. You probably want to see the actual code, and I don't want these videos to be too long anyway. I want them to be informative, not boring. Okay, so did I get this one already? All right, there we go. We're good to go. Now we can go over and actually code in our first little piece. First thing we got to do, again, I always like to put the engine in here. I did do some debugging using it before. Who knows, I might need it again. I don't want to have to think about remembering. So we're going to start by getting rid of that first enable tick piece, and we're going to start with creating our object. This here should be pretty standard, so I'll go ahead and type this out and get it created. this here, it's actually the setup attachment is what we're going to do. And we're going to attach this to the root component. All right, so that all being said, I think this is pretty standard. We're creating our scene component and we're going to make it our root component. And then we're going to actually work on our mesh component, which is, of course, the procedural mesh component. And we're attaching it to our newly defined root. Our two overload functions, we have to remember to not type virtual, but to type super to call the method back to the original owner. So that one will run. So this one here is going to be post actor created. Oh, look, how did I forget that? Thanks. There we go. That is an important piece. All else fails, just copy paste it. And this method here, all this one's going to do is call our generate mesh. All right. So like I said, we're going to do is call generate mesh. Perfect. So for this one here is going to be post load. All right. So again, I hope you remember what those two do. If you don't do it in this order, and make sure to call our actual generator, you're going to drop this into the world and get nothing. It's not going to break, but you're not going to see anything either. All right. So the next thing we're going to do is go ahead and define our method for the triangle. Actually, you know what? Let's start with the mesh. All right, so when generating the mesh, took me the hard way to figure this one out because I moved it from the tutorials thinking it was wrong, or I should say not wrong because it worked, but not needed. We're gonna need resets. So every time our generate mesh is called, we are going to reset all of these variables here. Okay, so we can just copy this, paste them in. Yes, this is how I do most things. I hate typing. And it's noisy. I know because my son tells me. And we're going to need this on all of them. We're going to come back to this later on for sure. Suffice it to say, to answer somebody's question, this is a key component when you are wanting to update your material from within the game world via variables. All right, moving forward. Another thing we're going to need to be able to do is keep track of the triangles. Out of all this, I think that's the most important, are these fandangle triangles. So what I do is I just create a index buffer, and we can just call it what it actually is. It is called an index buffer. Oh, it's not the buffer itself though. This is just the index count. We'll stick with what I normally do. And it's going to start right at 0. Okay. From here, let's see, checking my notes. Yeah, no, actually it's pretty simple. We might not even need this for the first time around, but we'll use it and, you know, all that. And some of this might seem like, wow, this was a little bit more code than what's needed, but it'll all make sense. Now, what we're going to do is we're going to create an F vector, and we're going to call this defined shape. And right now we are going to make it an array. We know we're doing a triangle, so we'll say an array of 3. And we're not going to set it to anything. We'll do that later. And then the other thing we're going to need is the tangent. Again, only because I don't know the actual formula to figure this out on the fly. Okay, so to recap, so far what we have is our general skeleton of what we officially need, with the exception of this method here. But this here is essentially the building blocks. Okay, and the one thing I haven't done yet is build it. Let's see if I am successful or if I'm going to crash and burn and look like a silly little man. All right, so it's giving me an issue with my post actor created. I'm not quite sure why. Spelling looks correct. Oh. I bet you guys all saw that and was like, yo, dummy. Open and close parentheses. All right. Moving past that oversight. All right, so we have a perfect build. Good. All right, so in our index buffer, we're going to do a couple of different things. I'm actually even going to change my note code too. I was looking at it and going, I wonder if I can do this a little differently, and I think I can. So first off, we're going to need is to keep track. Might be a different way of doing this, but I find this is better to be able to see what is going on. So we're going to do an int32.1, and we're going to pass it in our try index. And then once it's passed in, we're going to increment our index by 1. There are 3 points, so we're going to do this 3 times. And what this will do is keep our index number continually growing, because passing it in through a reference means when we change it here, it changes there as well. All right, so that being said, we can continue down to our vertices. The next thing we're going to address is that. We're going to add vertice, and we already know the order. We're just going to do them right in order as we pass them in. Here's our top left. I have 3 of those. So top left, what is this one? Bottom left. And then of course, bottom right. And there are our vertices. They're all added to our buffer. And that's going to be good. Now, the last thing we have to do is add our triangles. And to do that, I know, no surprise, right? And then the second and the third. And that order does matter. So make note if you don't already know that. Again, it's just mirroring this. So we're making sure to put them in reverse order. All right. And again, using the index buffer, what we're doing is because this is our first vertex that we're putting in, and this, say 10 iterations later, is still going to keep track of the try index buffer. And that's why I'm using this as the counter. In the end, this will actually be the official count. So the first pointer is this one, second pointer is going to end up being this one, third one is going to be this one. You know, because we know we're passing in 3 different vertices, so increment it 3 times. And then use those 3 and figure out your pattern for your triangles. So the next thing we need to do is figure out the normals. Now, there is a couple of different ways of doing this. Unreal Engine gives us a very handy feature to do this already. So let me go ahead and explain. Essentially, the normal or the math behind determining which way is the front-facing vector. It's actually from our wonderful linear algebra class. Took me a minute to remember this, but yo, I did. So coming back to our board here. Let me just go ahead, move this kind of out of the way. Actually, we probably won't even need it again. All right. So to figure out on our triangle which way is facing forward, we have to find the cross product of 2 vectors. Okay, so what we're going to do is there's a method that we're going to use that's going to tell us where this is facing. So to do that, we got to pass it in 2 vectors. For the triangle, I just pass it in this one and let it kind of do its thing. For a quad, what we're actually going to do is a little bit trickier than that, and we'll get in. But again, essentially, we need to find out which way is facing forward. And you'll see, we're going to do more of a math math inside of the method. We're going to take the difference. I'll just explain it now. This is the order I always do it in. I don't know why. You'll see this over and over again. Well, I do know why, because I know the pattern. So I do A, B, C, D. And then that is my order for the triangles. You know, so I always do this, this, this. And then I will do just the opposite. Take this one to that one to this one. That being said, when figuring out the normal for this, we're going to take the difference between A minus D, I think. I'll have to look at my notes. And then we're going to pass in the other vector, A minus C, and then A minus D. It could be reversed, but we'll go back to that. So back to the code. So that being said, what we're going to do is figure out the normal for this vector. We're going to make a temporary vector, call it this norm, and this is going to be F vector. And we're going to tap into that and do the cross product. And we're going to pass it in the top left and the, what did I say? Bottom right. You could probably do the bottom left too, and you will get the same result. Not the same result, but a different result, but kind of the same concept. And then just to make sure that, you know, our math is correct, Unreal has a checker called get safe. So all else fails, use that method, which I do. and that'll make sure that you got a safe normal to be able to use. Now this here, you could do a couple different ways. You can do it either as a for loop or whatever, which I do only because we're going to throw in some other stuff. Otherwise, you could literally go line by line like I've done up here and just do 3 for each one. But with this in mind, I typically will set all the other variables as well. Normals.add, and we're going to add this normal tangents.add, and we're going to add in the tangent that we brought into it. And then, of course, the last one is the colors. We're going to go ahead and do colors, add. And again, you could get more creative and do this a little bit more dynamic, but I'm just going to set them all to green. Go away, you're bothering me. All right, or don't go away, I don't care. Now the UVs, not so much the same way. We have to do them a little differently. Well, you don't have to, but I do. All right, only because of the way the F vectors work. So we know we need to pass in F vector 2Ds, and there is a formula you can use on this as well. Again, it escapes me. So for the first one, I always put 0, 0. The second one, I do 0, 0 as well. I'll explain why in a minute. Let me just go ahead and put a disclaimer. I could have this order wrong, but that is the basic concept. Now that I'm thinking about it, 0 to the X, 1 up, top left. 0, 0 is the origin, and then 1, 0 is 1 over up none, right? Perfect. All right, hopefully that all makes sense. We're gonna go ahead and save that. Again, I know I'm going a little bit above and beyond kind of what was given to us. However, it still doesn't like that. Yeah, I knew it didn't like that. Why didn't it? Passing a tangent. Let's comment that out and see what we get. Oh, I see the error there though. I can uncomment that now. Can you see what it was? It was passing itself into itself. I noticed by fixing this, it fixed everything else. So sometimes you can't go by order of how the errors come in. You have to look below. Lesson learned. So now what we're going to do is just define our cube, or in this case, our triangle. And we know it has 3 shapes, 3 vertices. So let's go ahead and get this defined. So we do have our radius that we did create, so we'll just go ahead and start using that right off the bat. What was that called? Do you remember? I don't remember. Let's check. Cube radius. And because I'm lazy, remember these are all set to 100. We're going to pass this in a whole bunch of cube radiuses. Dot X, dot Y, and dot Z. And if you don't know, why didn't I just assign it? You know, because you could, I could just, of course, just pass it in, and that would apply it. It doesn't give our shape any form. So now that I have the basis of this, I'm just going to copy paste it, and I'll show you what I mean by form. Okay, so we know that we want a triangle with our top left. Well, we know the shape. So looks like I got an extra character in there. So like I said, for the first one, the top, we're just going to leave them all to 1 because we want it forward to the right. And now that I'm thinking about it, to the right, if it's facing you. Yeah, okay, if it's facing you, it's to its right, not your right. Keep that in mind. Your object's right. If the object is facing you, its right is your left. And then we're going to start in the up vector. So now coming in here to the next one, you have to remember, if you're doing the copy paste, to change all these. There you go. And then this one here, all these are actually going to be in the positive direction. We're all forward. This one here, it's the second side, so it's the bottom. And then this one is going to be in the negative. And then the other one we know is in the down position as well, and we're going to be on the left side. So this here is the basis of our shape. We defined the points in space for our shape. Now, all we have to do is pass that in to generate the mesh. This is actually done pretty simply. First thing we're going to do is we're going to set up our tangent that we created, that temporary one. So tangent setup, and we're going to set this equal to an fproc tangent, and we're going to set it to a 0, 1, 0. So the reason for that, okay, it's like I said before, a tangent is a 90-degree angle or perpendicular to the normal. We know the normal on this is actually facing forward in the X direction. So a 90-degree angle of that would technically be either a -1 or 1. So therefore we're going to go 1 to the right direction. And that's our tangent. And the next thing we have to do is just call our add triangle mesh, where we pass in our defined points. Keeping in mind, we also have to pass in our triangle index count. And again, that passes in as a reference. And then we're going to pass in our tangent setup. And that is our function call. Did you see? Let me see if I can get that back up again. The advantage of the IntelliSense when you're using proper names is it kind of gives you the idea as to what you need to pass it at. So we need the top left, the bottom left, and then the bottom right. Kind of a useful little thing. So theoretically speaking, that will get that generated for us. But we're not done. Nope. One more thing we have to do, and that is to actually get our program to apply that and create the actual shape. And we can do that right from here. We'll call our mesh and create mesh section, linear color. This first variable is going to be nothing. So set it to 0. And then we're just going to pass in, literally, we named them all the way they are. So vertices, and then our triangles, pass in our normals, our UVs. Don't forget our colors, tangents. And the last variable, hopefully you can see it, it's just, is it there collision? Yeah, of course. And in a sense, if we build this, that should give us what we wanted. Our desired results should be met. Perfect. Let's pull up our editor and call it basic shapes. I'll drag that out. Okay, so why did it show me there? Why didn't it just show up perfectly where I wanted it to? Well, see this? That's pointing to the world's forward position. The world's forward position is over there. And therefore, our object's forward position is over there as well. The odd part is I don't have handles to be able to drag that thing up, which is really weird to me. Where's my handles? All right, I'm going to play stupid and think it's a system glitch, but there you go. Notice you can't see it from the back, but you can see it forward, and it is the shape that we wanted. And top left, and bottom right. Okay, this video is really kind of long at over 30 minutes, so we're going to break it up here in the middle. The next part will take over the creating of the quad.